Have you ever stopped to wonder why spiders feel like something straight out of an alien world? 8 legs moving silently through the shadows, webs that trap far more than just insects. These creatures have been around for over 400 million years, survived the dinosaurs, and reshaped life on Earth in ways most people never think about or simply choose to ignore. What if I told you they're not just survivors, but true masters of innovation? Animals capable of drifting across oceans using silk parachutes, or turning their own bodies into living sensors. Stay with me, because once you look behind the curtain, you'll never see that small spider in the corner of your room the same way again. Now imagine a world without trees, flowers, or forests. Just rocky coastlines and primitive mosses under a hostile sky. That was Earth when spiders first appeared, roughly 400 to 450 million years ago during the Silurian and Devonian periods. Life was only beginning to colonize land, and these early arachnids were among the pioneers. They evolved from marine ancestors that looked nothing like modern insects. In fact, spiders split from the insect lineage more than 500 million years ago, following a completely different evolutionary path as chelicerates relatives of scorpions and even horseshoe crabs. No wings, no antennae, just 8 powerful legs and a 2-part body built to survive the harsh conditions of early terrestrial life. The earliest fossils reveal creatures that seem almost alien. Segmented abdomens, short, tail-like structures, forms very different from the spiders we know today. These early models hunted in swampy landscapes filled with giant ferns, preying on massive arthropods long before bees buzzed or butterflies existed. It's astonishing to realize that spiders were once top predators in a world we would barely recognize. To survive dry air and scarce food, they refined senses based on vibration rather than sight. What drove these changes? Life on a constantly shifting planet where every mutation could mean dominance or extinction. So what makes spiders such efficient killers? Their venom didn't start as a weapon. It began as simple digestive enzymes inside the gut. Over millions of years, these chemicals migrated to glands near the fangs, allowing spiders to inject them directly into their prey. Imagine biting your food and watching it liquefy before you even swallow. That's everyday life for a spider. Over time, venom evolved into complex neurotoxins that paralyze prey instantly, avoiding dangerous struggles. In Australia, funnel web spiders possess venom capable of harming humans without rapid treatment. Still, most spider venom isn't designed to kill large animals. Its primary role is to break down the prey from the inside out, turning solid tissue into a liquid meal. Some venoms act like anesthetics, others disrupt muscle control. Its chemistry refined into an art form, giving tiny predators an edge in a dangerous world. If venom is the silent strike, silk is the real revolution. This material, stronger than steel by weight and more flexible than rubber, began appearing around 380 million years ago. At first, silk was used simply to protect eggs. Later, spiders lined their burrows with it and eventually began spinning aerial traps that transformed hunting forever. Modern spiders can produce up to 7 different types of silk, each with a specialized function. Structural threads form the web's framework. Sticky spirals capture flying insects, and wrapping silk immobilizes prey like a living cocoon. Think of the golden silk of orb weavers, or the massive webs of Darwin's bark spider, stretching across entire rivers and stronger than bulletproof vests. Some spiders abandon webs entirely. Bola spiders swing sticky globules like tiny cowboys. Aquatic species build underwater air bubbles they can breathe from. And ballooning spiders ride the wind for miles, sometimes even crossing oceans. Perhaps most impressive of all, many orb-weaving spiders rebuild their webs every single day, consuming the old silk to recycle nutrients and adjusting the design to weather and insect traffic. Spiders' bodies are filled with almost unbelievable adaptations. Most have 8 eyes, but jumping spiders take vision to another level. Their front-facing eyes work like miniature telescopes, with internal layers that move to focus without the spider even shifting its head. They see ultraviolet light, judge depth using color shifts, and can leap up to 50 times their own body length. No extensor muscles? No problem. Spiders use hydraulic pressure from their blood to extend their legs, like tiny biological pistons. When that pressure disappears after death, The legs curl inward, explaining those eerie postures we often see. Hunting strategies get even stranger. Crab spiders vanish into flowers. Ant-mimicking spiders infiltrate entire colonies. And jumping spiders like Portia display astonishing intelligence, navigating enemy webs, planning detours, and avoiding detection, all with a brain smaller than a grain of rice. Today, spiders continue to surprise scientists. New species are still being discovered, including a rare intersex spider in Thailand and the trapdoor spider of California's dunes, Aptostichus ramirezi. As the climate warms, tropical species are pushing northward, reshaping ecosystems. On isolated islands, some spiders are even shrinking their genomes, challenging long-standing evolutionary assumptions. One thing is certain: spiders are incredibly resilient survivors of mass extinctions that wiped out giants. Spiders are not just creatures of fear, they are ancient engineers, mastering venom, silk, and sensory systems in ways that still outperform our technology. In a world full of misinformation and rapid environmental change, who knows what they may yet become? Perhaps they'll integrate even further into our human world, or perhaps they'll outlast us entirely on a post-human Earth. So the next time you see a spider, pause for a moment and consider this. Could something so small be carrying secrets that challenge our very definition of intelligence? If you're interested in seeing NASA's wild spider eggs discovery on Mars, hit that next video. It's insane.